right, day 2 for P4. We're going to be looking at a whole lot of solving with different methods, so it is a little bit long, and we need to also see how our calculator works with that. So the very first example that we're going to look at is if you're given a picture, and here we're going to have a picture of a semicircle that has this kind of shape to it, and you're asked, what is the x-intercept and what is the y-intercept? All you're going to do is just look at the picture. What is the x-intercept? The x-intercept is -1 and 3. What is the y-intercept? It is 2, because that's where it crosses the axes. That's where it crosses the graph. Now, be careful with the directions. For any kind of homework kind of questions, whatever, I'm good with answering it in this format. However, there will be some quizzes and tests and stuff that come up that will be very specific, that says your x-intercepts and y-intercepts need to be in ordered pair format. So if it does ask for an ordered pair, you need to make sure you write it as an ordered pair, because it would be marked incorrect. But if it doesn't specify how you need to write it, this is okay as well. Alright, so here we're going to have, from an equation, we're going to solve to find the intercepts. Alright, we're going to start with an absolute value. Now, when it comes to absolute values, little bells and whistles should be going off, because absolute values are special. First of all, we are going to substitute, we're going to make y 0 to find x. So when I do that, I get 0 is 3 minus 1/2 x plus 1. I get -3 is -1/2 x plus 1. I get 6 is the absolute value of x plus 1. This is where your little bells and whistles go off. When it comes to absolute values, you always do them twice. You're doing it once as is, and then once where you are changing the signs of everything outside of the absolute value. So the 6 becomes a -6. So now we get to ignore the absolute value part of it and get x is 5. And on the other side, we're going to get x is -7. That means we are going to have 2 x-intercepts. One's at 5, one of them is at -7. Alright, so now let's look at going the other direction. We are going to make x 0 to find the y. So here we're going to get y is 3 minus 1/2, 0 plus 1. Well, that's 3 minus 1/2 absolute value of 1, which is 3 minus 1/2, which is 2.5. So in this case, we only have one y-intercept, 2.5. 2 x-intercepts, 1 y-intercept, but nonetheless, those are our intercepts. And again, pay attention to the directions. If they do want it in ordered pair format, make sure we write it in the correct form. All right, moving on with day 2 of P4. Again, we're going to find an x-intercept. We just talked about it algebraically, where we set y equal to 0. So given the equation, y equals 20 minus 3x minus 10, we would make y 0 and do some simplification process. And then get that our x-intercept is 10. Now, that's our algebraic. We need to be able to look at our other formats. So let's look at graphically using our graphing calculator. So go ahead, pull out your graphing calculator. Let's see if we can get this to not have a shiny spot on it. And when we do this, we want to make sure that our equation, let's see, there we are, is solved for y, and it is 20 minus parentheses 3x minus 10. So when we go to y equals, that's exactly what we're going to put in our calculator. 20 minus parentheses 3x minus 10. I don't need to make any changes or do anything. Now I'm going to graph it. And I do see part of that line. I don't necessarily maybe see all of it, so I might want to change my window, because if I'm going to find an x-intercept, and that is what we found, see, find x-intercept. This is the x-intercept crossing at 10. This is what we found by hand for math. So in our picture, it needs to cross at this x value of 10 as well. So maybe it's there, maybe it's not. I'm just going to change my window so that it goes out just a little bit farther. And I changed it to x max of 12 so that I could clearly see what that is. Alright, so if I'm going to use my graphing calculator, I first go to y equals and I input the equation. I graph it. I adjusted the window. Now, in order to verify that that is 10, what we just did by hand, we're going to go through a process where we're going to hit second and calculate, which is also the trace key. Here's our trace key, but above that is calculate. So second, calculate. And we're going to go to 0, because 0 is the same as x-intercept, it's the same as root. Those words are all intertwined. So we're going to go to 0. Option number 2. And then the calculator is going to ask us some questions. We have this little flashing spider somewhere, and if you don't see it, you need to move to where you can. And I'm just moving my mouse right and left. I know I'm over here in x value of 10, so that's what I'm looking at. I'm looking here at my x value. Okay, there's my flashing spider. The calculator is saying, give me boundaries of where you think the 0 is, the x-intercept. So it says, tell me the spider is left of the 0. Well, here's my spider, here's my 0, and it is left. So I can just hit enter. Then it's going to say, well, now move the spider so you're right of it. So I'm going to move my spider until I'm right of the point I think is the 0. So I think the 0 is here. The spider's now to the right. And I can be close, I can be far. As long as I'm right, it doesn't matter. And hit enter. And then it says, are you sure? And all you do is hit enter. And the spider will jump to the x-intercept on the x-axis. And we do find that, yes, it is the point 10, 0, which is what we found by hand. So we need to know how our graphing calculator is going to help us verify and do the work that we're going to have to show by hand. All right, now we're going to go to two equations. We have 2x plus y is 6 minus x plus y is 0. Now last year we learned that we could do this with substitution, we could do this with elimination, we could do these graphically. I'm going to show it with the elimination part. So elimination means I need to get one of my x's or y's to be able to cancel out. And the way I'm going to do that is I'm just going to multiply the second one by a negative so that the first one stays and the second one becomes positive x, negative y, and 0. So I get 3x is 6, x is 2. I then take that and substitute it back into one of my originals. So 2 times 2, I'm just picking the first one. So 4 plus y, so y is 2. So I'm saying that these two equations meet at the point 2, 2. Well, this is what we did by hand, and this is what you've done by hand several times over, you know, in Algebra 1 and in Algebra 3, 4. So now let's move on to the graphing calculator. How does that work for us? So with our graphing calculator method, we again want to go to y equals, and we're going to input the equations into y1 and y2. So you got to do a little bit of solving, because on the first one, you're going to get y equals negative 2x plus 6. And the second one is going to be y equals x. Graph. There's our two graphs that came up. Now to find that intersection that's here, we have a function under second and calculate. Second, calculate. And the option we want, intersect. Option 5. The calculator is going to ask you a question saying, is the spider on the first line? Well, here's the first line, negative 2x plus 6. Is the spider on it? Yes. Hit enter. Then it asked, was it on the second one? And y equals x, yes, there it is. Hit enter. And then it says, are you sure? And you just hit enter. So you just enter 3 times. Notice the spider jumps to where the two lines meet. And down here are those coordinate points of 2, 2, which is exactly what we found by hand. Okay. This works even if we are not doing 2 lines, but if we're doing a line and a parabola or a quadratic. I can solve these the exact same way. I can set them up and I can notice that, oh, I can get rid of y's if I multiply by a negative. So I'm going to multiply the top one by a negative. So I get negative 3x minus y is 2. And on the bottom, I'm going to leave that one. So when I put these together, the y's do go away, but it leaves x squared minus 3x is 2. Hopefully we remember from last year, if we have a quadratic or a parabola, it has to equal 0. So we need to move that 2 over so that, we forgot that negative up there. This is a negative. This will be a negative, which makes that a positive. So that we can factor. So this is going to be x minus 2, x minus 1, so that x is 2, and 1. That shows us we have two x-intercepts. I need to plug them in order to find, or I'm not sorry, those aren't x-intercepts, those are the x-coordinate points of the intersection. I plug in the 2 and 1 into one of my equations. I'm just picking the first one. So 3 times 2 plus y is going to give me y is -4, so that means 2, -4 should be an intersection. And then I'm going to do it again, but this time I'm going to do it for 1. So I'm going to get y is -1, so again, the intersection point should be 1, -1. Let's use our calculator to verify that. We're going to go to y equals, and we're going to put in the two equations that we have, but they have to be solved for y. So the first one is going to be -3x plus 2. And the second one is going to be y equals -x squared. If I graph that, there's the line, there's the parabola. Alright, now over here we can't really see very clearly where the intersection is, so I could zoom in on that. I can do that by changing the window, or I can actually go to this zoom function and I can put a box around the part I want to see. So I find my flashing spider, there's my flashing spider, and I look at what I want to see. Perhaps, let's see, we start there and head down, and I'm not going to get this because it looks like I'm going to miss that one. So I'm going to try again, zoom, and I'm going to come out a little bit farther. There, that looks good. Okay, and I'm going to go up and just zoom in on the part I want to see. There's the line. Ooh, and there's a parabola. So notice we can see that just a little bit better. So I can do that intersection. Second, calculate intersect. And notice I'm down here. So I'm probably looking for this intersection right here. So am I in the first curve? I look up here at this. This is my line. Yes, enter. Second, yes, enter, enter. And it's going to jump to -4. That's one of them that we found by hand. So if I want this other one that's up here, I just have to repeat the process. Second, calculate, intersect. But this time I want to move my spider closer to it. Otherwise it's just going to go back to the same exact point. There you go, that's closer. First curve, second curve, are you sure? Yes, enter, enter, enter. And it jumps 1, -1. It verifies what we did by hand. So make sure you understand how to do it by hand, and you know how to do it with our graphing calculator. Alright, the last one that we're going to do for today is being able to look at a quadratic. We're going to solve a quadratic by factoring. So x squared minus 10x plus 9 is 0. All of our quadratics have to equal 0 in order to solve it. We do have different ways of being able to solve it, but for today we're just going to look at the factoring. The next lesson we'll complete the square, quadratic formula, square root, and we'll try different options. But for this one, we're just going to be able to factor. And factoring is something you should be able to do inside, outside, backwards, and every other direction, because you should have spent a ton of time on it in the last couple of years on it. So what multiplies to be 9 and adds to be -10, you should get x minus 9, x minus 1. Therefore, the x-intercepts are +9 and +1. Let's look at one more here. 2x squared equals 19x plus 33. Always want it to equal 0, and we always want our square to be positive. So we're going to move the 19x, and we're going to move the 33 so that it equals 0. You should be very comfortable and confident in factoring with a leading coefficient. 2x can only be a 2x and an x. Now, with the 33, you don't have too many options. You have 1 and 33, or you have 3 and 11. And you just got to trial and error it, see which ones work, and make sure that you check your inners and outers so that you get the 19 in the middle. So let's go with plus 3 minus 11, and again, just check it. Check to make sure. This is 3, this is minus 22. Yes, that is negative 19. So when I solve this, my x-intercepts are negative 3/2 and positive 11. All, again, can be verified on your calculator. For example, this one right here, this 0, because it's an x-intercept, tells me that the y value is 0. So that's my y. This is my y. This is my equation. So when I plug it in the calculator, 2x squared minus 19x minus 33, and graph it, we need to go back. Normal, zoom, 6 is how we get to a normal window. Alright, we see this negative 3/2. We don't see the 11 because on a normal window, this is a 10 by 10. So if I want to be bigger, I can extend this out maybe to 12 so that I can see, oh, it went down at negative 3/2, it came back up at 11. So those are my x-intercepts. And if you're unsure, again, we can go second calculate, and you can go through the 0 process that we practiced back on a couple of examples. The other one, just really quickly, x squared minus 10x plus 9, graph it, there's your 2, positive 9, positive 1, matches up with what we found. Alright, so that should cover your intercepts and being able to solve those for the second assignment on P4.